I'm going to demonstrate how to design a PCB, printed circuit board on a Raspberry Pi. So it's a simple piece of software. All you need to do is to install the software. You just give sudo get install. It's called KiCad. I've already got it installed, so it should just come back and tell me it's already installed. So once that's installed, all you have to do is type KiCad on the command line, hit return, and that should load up the application. And we start a new project. So I'll just click here, and you just tell it where you want it to go. So I've got a directory on my desktop called KiCad. I'll just create a demo project here. And when you click on save, it will say, do you want to create a directory for the project? Just say yes, unless you've already manually created one. So I've got the project, an empty project here. The first thing you have to do is create a schema for your project. So I'm going to just do a simple flip-flop project. I've run through this manually myself just to try and make it hopefully reasonably quick to demonstrate on this video. So it's when you design a schema, it's literally just about placing components, then creating tracks between them. So what I'm going to do is add the components that I need onto the desktop. So if you select by browser, it's a bit easier to do. And most of the things you want are in this library called device. So I'm going to want a capacitor, but it's electrolytic capacitor. So I add that, I add one of those. I just get one of each of the components that I want to put on. The actual process of doing this is quite lengthy typically, but I've tried to go through this and hopefully make it reasonably quick, this demo, of a kind of a meaningful project. So I've got an LED as well. And a connector. So I just use the connector as a way of getting power onto the board. I just want a 4-pin connector. And then the last one. I think what you probably find is you need to add like custom things in your libraries, because it won't because KiCad won't have all of the devices you want. But in preferences, you can add your own. Well, this is a library I've created earlier. I won't go through how to create a library in this particular video. This is just quickly how to design a PCB. But if you click on Add here, you can add the library you've created previously. So it's in my KiCad library here. So now, when I place a component, hopefully I should have my library in this list at the top, I think it is. There. And I've created this transistor. So I've also placed from the other libraries the capacitors that I typically need for this project in here. So it's probably good. It's nice to, if you've got common components you're always using, just place them in your library, place copies of them. So if I place this transistor now. Okay, so these are all the components I need. So I'll just move them around a bit. So by right-clicking, you get the context menu. There's shortcuts that you can see on there. I haven't learned the shortcuts, but it's probably a lot quicker to do this if you know the shortcuts. So I'm going to copy this resistor, copy component. So if I just press C, so I might try that actually. So I want some more of these. So if I just click once on it and then press, maybe just hover over it and press C. No, I'm not sure how to use the shortcuts. Copy copy component. Move this connector out of the way. Just copy it again. Doesn't matter exactly about placing at the minute these components. I'm going to place the LEDs now. Oops, accidentally zoomed in. I'm going to take component and you can rotate them. Let's just zoom out again. And I'll move the LED to where I want it. And I want another LED for the other side. So I'll copy that. Place it there. Then I'll place the capacitors, so I want to rotate that. And move it. I'll have another copy of that one. Orientate the component. I just create a horizontal mirror. Move it over here. Just zoom in a bit to get a better view of this. Okay, so next I'm going to position the transistors. So this one I'm going to have over this side here. I want to copy that, make a mirror of it. And move it into place over this side. Okay, so once I've moved this connector, it's there. Okay, so now I want to start laying down tracks for these between the components. So I want a track there, and it's literally just a matter of putting the tracks where you need them. I won't spend any time like laying this out neatly. I just like quickly get it down and then go straight to designing the PCB so we can see how the PCB is designed. Okay, so lucky enough there's not too many tracks on this demo. Track there, then on track the connector. Now on these two connectors that I'm not using, I should put a no connection, but I'm going to leave it without them so you can see what happens when there's an error on the board, and I can come back and correct the error. And if you want to put a diagonal line, if you just put a line to, then double click to end the line like that, and then when you go back and right click on it, you can say drag wire, and then you can put a diagonal line in. Quite handy for keeping this kind of neat. So right click and drag wire again. Okay, so these points here, which are junctions, I need to put like a junction point on so it knows that they are all connected together. And that's okay. I think there's possibly another junction. Oh yeah, here. Junctions there. Okay, so that's the schema laid out. Now, there's a few stage process now. So you can see these resistors, they're just R question mark, R question mark, R question mark. So it doesn't know the difference between these. So, and same with the diodes and all the other components. So the first thing you do is annotate. So you click on this icon, you tell it to annotate, okay, close, and then we should see, yeah, it's named them R1, R2, R3, R4. So it automatically goes around and names all your components uniquely. Then you can do an error check. So this bug thing, and then click test ERC, and you find there's a few errors on here. So if I double click on one of these, it will take me to where the errors are. So these two places where there's no connects, and also I didn't quite drag that track fully across. So I'll put the no connect in here just to demonstrate how it shows you errors. And then right click on there and drag wire, and you can just drag it up to the place where it's supposed to be. So just move across so you can see the whole thing. So I'll run the error check again. Hopefully this time there should be no errors. Yep, so no errors. So close that. So that's good. So then the next thing we do is we create this net list. So this is what we use to actually generate the PCB. So almost at the PCB designing phase. Just click save as the default name. But we need one more thing before we go and design the PCB, and we need to associate the modules, like the type, the components which go on there, associate them with the actual schematic diagram that we've created. So if you click on this one, it comes in and it lists all of the components you've got, and then what you have to do is you have to associate from a list of modules on the right here to each component. So, and there's a little icon here which you can see what the component looks like. So you can see that looks like that. So I think what this one is it was one of, you can filter it differently on this by clicking the icons at the top. So I think C1 V8 might be it. Let's just look at that. Yeah, so it's like an electrolytic capacitor. So I'll select both of those as electrolytics, and if I just press L now in the right hand side, I'll go down to the LED section, and I'll make these 5mm LEDs. And then the connector, I'll come back to it in a second because I've had to design that myself. The transistor, I think if you select on this, it automatically selects the right one, so I'll just use that. Then the resistor, I'll just see what this one looks like. I want one that's laid down yet, so that's laid down. So I can select all my resistors as being those. Now the connector, I'm pretty sure it hasn't got my designed one here. No, because it'd be in here somewhere. So I've got a library of my own modules as well. I've only put one thing in it at the minute. So you can add your own library in under preferences. And if I go to the project, it's one above. So there's the library. So once you add that, hopefully it should then come in here, and here it is, 4-pin con. So I can now associate that. Okay, so save that. So that's the association done. And now we actually go to the design of the layout. So I can close this and say save and exit. We go into this icon here. All we have to do is import the netlist, so read current netlist from the project. And what it's done is it's put all the components. I'll just zoom out a little bit. Just put them all in this top corner here. So when you create a dragged box like that, you can select things within the dragged box. So just click on OK, and then we can move the whole of all of the components to the middle of the drawing. And then I can zoom in on that. Now it's a little bit time consuming, this, and a little bit annoying, but you have to now select each of your footprints, which is each component, and drag them out onto your board initially. So I'll just go through that. It'll take a little while, but to get sort of a layout like this. And like I say, I'm not going to spend lots of time making this look neat. I'll just quickly show you how to design the PCB. frustrating. Dragging this stuff around. Connect this up about the top. Let's move up a bit. Once all these are laid out, it becomes a lot quicker just to draw the tracks between them. It's a shame it doesn't lay them out sort of in a way that you can just like quickly do what you need to do. Almost there now. I think it's the last component. Okay, so because I know kind of roughly how I'm going to lay this out anyway, I've got an advantage just to like demonstrate stuff. I think I want these capacitors around the other way. Oops. Accidentally drag the pad. You can accidentally drag pads and stuff, and so you have to be careful about that. I want this capacitor at the top. I want to rotate this transistor twice. Okay, so, and if I rotate these resistors, then I'll start laying the tracks down. I think learning shortcuts keys would be a definite advantage in this. So I can go to the tracks, like I said, I'm not going to be neat about this. And you just lay tracks down between the components. Double click to end, so that's the track between the bottoms of the resistors. I can also bring a track around the side up to the connector. So where the white lines are, these are the tracks you have to complete, and the green line is the track on the bottom. Now you can create two top and bottom 2-layer boards, because you have that didn't quite go right. Because you have 2 copper layers on this. I'll get there in a second. I'll come back to that. I'll show up as an error, I think. So you got this top layer and the bottom layer that you can put tracks on. You can make links between the two. Just finish laying out these tracks. It shouldn't be too long now. I need to rotate this. Sometimes it's easier just to end the tool that you're on and then done. So I can finish laying. Yeah, sometimes it's easier to select the components when you're not in, even though you should be able to when you're in a tool, but yeah, to select the components. Sometimes it's easier just to unselect the components. Looks like I have to rotate. You have to, so end tool, yeah. Like that, and then it's easier to find the component then. So why that is. So slowly the white lines are disappearing as I'm filling out these tracks. You have to be careful not to like cross tracks and stuff. And where I've got kink there, I won't worry about that, but I'd iron that out normally. But bring this into the middle bit. Yep, it's hung. Oh, that's good. My Raspberry Pi is hung for a little while there. I think I may have rotated that the wrong way around. Need to be a bit creative now, just to get so they don't cross tracks. I'll just bring this LED up. Oops. Around there. Okay, only a couple more to do, I think. I may be showing how to go through, do a link through the board, but I think this one is, I did have it, so it was on the single-sided board before, but I'm not quite sure why I haven't got that. For quickness sake, what I'll do is I'll show you how to do through holes. So if you're dragging a wire out, and if you right click, you can do a place via, and this you're now on the top side of the board. So if I right click now and do another place via, I'm back on the bottom side of the board, so you can quickly go do two-sided boards. So I've got that one out of the way. Now I'll do the same for this. I'll do a place via here, just for quickness. So with this two-sided board, you can either think of them as two-sided boards, and actually they are two-sided boards, or on a single-sided board, you can use a place via as a quick wire link. So if you want to put wire link in, and that'll be a wire link there. So that looks like that's done. So now do a test for errors on the PCB, and so there's no errors. They'd come up down the bottom here if there was. So that's good. So now that you've designed your PCB, you've got this schematic. The only thing you need to do now is actually create files to send to the manufacturers or to use yourself to generate the boards, to do etchings. So under this plot stuff, you can select your file format here. So I think Gerber is probably one that's used a lot. And then if you click on plot, it generates a plot of it, and then generate drill file. So you select your options throughout here, Gerber again, drill file, map file, and report file. So click on each of those, and it generates those. So close those. So now we should have generated the files we need, I think. One thing, I won't actually do it in here because I'm on a VNC session. It seems to kill the VNC session, but you can get a 3D display of your board as well, which is quite nice to see. So I'll close this PCB design, save and exit. So these are my files in here. So there's one other thing which I'm going to show, which is there's a Gerber view tool. So the files that we've generated, we can actually open them up and take a look at them. So click on that icon, and it shows you the things you've got. So we've got bottom copper layer. So if I open that up, and so it's opened up the file there, so you can review that. And then you've got bottom silk screen. There's nothing on that. I don't think. There's a drill map, which is just the holes. So it overlays them onto what you've already loaded. So, and if I so this is the front copper layer. I'll clear it and show you the front copper layer just by itself in a second. And then the front silk screen. So the silk screen shows you the components on there as well. I'll zoom in a bit if I can. So this is these are Gerber files that are loaded. But what I'll do is I'll just load the front silk screen by itself. So if I do that, it clears all the layers. And then just load the drill map. That's what I was going to do. The drill map, so you can see. So these are the holes basically for drilling. So it's a good tool for seeing what it's created and verifying stuff. There's also a print option. So if you go back into the circuit board, PCB, it's loading it up. Okay. There's also a print option as well. So if you use the print option, I think you can create. You've got this real drill option and accurate scale. You can create a file which you can use on your own printer for creating something for etchings. So if you want to do etchings at home, you can do it in there, I think. So, which I'll have a go at another time. But that's basically how you design a printed circuit board on the Raspberry Pi with all free software. If you take your time a bit more, you can make it a lot neater, which I tend to do. I mean, you can spend days on doing like circuit boards, and but if you just want to quickly knock something together like I've done now, you can do that fairly quickly.